These are the parts of an Estes model rocket.
But how can you make these pieces of cardboard and plastic fly? The answer is with this tiny B64 engine. This engine creates propulsion, the means to drive or push an object forward.
Propulsion is the force that advances a person walking by pushing off the ground, that moves a strongly kicking swimmer through the water, and that sends a rocket into space.
But how does propulsion work? To better understand propulsion, let's look at this balloon. Right now, it is in equilibrium, meaning that all the gases are trapped and that the net force, the sum of all forces acting upon an object, are balanced. But when I release the balloon, all the gases escape, propelling it forward and creating thrust. This experiment demonstrates the concept of Newton's third law of motion, which states that every action has an equal and opposite reaction.
In this case, the force of the air escaping the balloon is the action force that creates the reaction force, thrust, that pushes the balloon forward.
Essentially showing how rockets propel themselves by turning fuel into hot gas. The engine pushes this gas out of the back of the rocket, which makes the rocket move forward, or, well, up. However, not all engines are created equal. There are three main types of engines: liquid, solid, and hybrid propellant engines. However, all three have the same general components: fuel, oxidizer, combustion chamber, and nozzle.
The fuel is a substance that burns, like liquid hydrogen, while an oxidizer is a substance that provides the oxygen necessary for the fuel to burn, like liquid oxygen. The combustion chamber is where the fuel and oxidizer chemically react to create the expanding gases which travel through the nozzle to generate thrust.
Let's see this in action. I have with me a baking soda rocket. If you want to follow along, click the link below.
In my rocket, my propellant is made from baking soda and vinegar. When they mix inside the bottle, or combustion chamber, a chemical reaction occurs that produces carbon dioxide gas, which builds up pressure until it builds enough to force its way out the nozzle and launch the rocket.
How do aerospace engineers know how much thrust an engine will produce?
The general thrust equation shows that the amount of thrust generated depends on the mass flow rate, which is a fancy way of saying how many kilograms of gas is expelled in 1 second, and the exit velocity, or how fast the expelled gas is moving.
However, no matter how much I increase the mass flow rate or the exit velocity of the solid rocket propellant B64 engine, this can only produce up to 12.1 newtons of thrust, which is perfect for hobbyists like myself, but if you want to get out of Earth's atmosphere, you're going to need way more force.
NASA's Artemis 1 rocket engine generated 39.1 million newtons of thrust during launch and ascent, over 3 million times more than my model rocket engine. That's a lot of force. In conclusion, propulsion is the force that will take rockets to the moon, Mars, and beyond.